Hello everyone. Yeah, thank you so much for inviting me, Mr. Ranji sir. And today in this session we are going to discuss about the electrical electronic measurements. Okay. So basically, as there are three types of people here. Okay, so I can just know about these things, right? Okay. So electrical students are there, electronic students are there, and similarly we have the computer science students are there. Okay, so the subject name you can just see here. Okay, so electrical and electronic measurements it is. And in this, what we are going to study and all. Okay, so I will be discussing within very short time. Okay, like only 2 or 3 minutes I will take to tell about what is our syllabus and what we are going to study in this. Okay. So basically, you may know about if any wire is there, okay, so if any wire is there, in that wire, so there will be some current flow if there is any closed path, okay. If any closed path is there, so there will be definitely some current flow and there should be some energy inside, okay. So current flow means there should be some energy inside, okay. So, and definitely, if any resistance is present in this one, so definitely across that resistance, you will be getting some voltage. Okay, so these are just the basic things only. So what is our aim means? So what is this voltage value? Okay, so we have to find out what is this voltage value, and similarly, what is this current value? Okay, so we need to understand why this is so important means. See, every day in our daily life or in our industry or our even organizations, we will be handling with so many electrical instruments. Okay, we may not notice, but even without our noticing only, we will be handling so many electrical devices. Okay, or electronic devices. Just for example, we will take our mobile. Okay, so our mobile needs some charge every time. Okay, so every time from 100 to 0, okay, so it will be decreasing, right, whenever we are using the mobile. So the screen is on. Is my voice okay? So or should I need to raise my voice? Just please confirm, okay, like this. If any problem with my voice or any video problem here, so then you can directly ask me, okay, anytime. Okay. Okay, so that's good. Okay, Balkrishna sir, that's good. Okay. So because we need best out of it, right? If you can't understand anything, you can ask me immediately. Okay, so I will repeat whatever you want. Immediately, I can repeat also. Okay. So hope it's good now. Our voice. Please, someone just respond. Is my voice okay?
Yes, okay, sir.
Yeah. Okay. Thank you so much. See, what we are doing is we need to find out the value of what the voltage value and current value. Only these things or some more things we need to find out. Whenever something, okay, so you see your device, okay, so many of you are using mobiles or your laptop screen. So just think, okay, so there will be some wattage, right? Wattage, like our bulbs are there in home, there will be some wattage. How much watts it will consume? So what is the power in that? Okay, so that load, how much power it will take? Okay, so that will be called as wattage. Okay, and similarly energy, how much energy by the end of the month, everyone in our home will be getting energy bill, or famously we may know about that one as a current bill. Okay, so we may know this one. Okay, I'm not asking any question, so we know this one. Okay, so every household, so we'll be getting current bill. Yes, right. So that means how they are calculating this current bill. So using some device, there should be some device, right? There should be some instrument. We will call as instrument. Okay. Okay. Instrument we are calling. Okay. So what is that instrument? Okay. Everybody can know about this instrument, but what is the operation of this instrument? In the exam, in our exams, okay, not only in our BSNL exam. So whatever exam it is, they won't ask the name of the instrument, right? They will ask a little bit more. Okay, so little bit more means operation of that instrument. Okay, so we need to find out operation. We need to know about operation of that instrument. Okay, so like this, all these things. Okay, whatever electrical quantities are there. Okay, so remember, whatever electrical quantities are there, for each and every quantity, electrical quantity, we need to find the value. Okay, so I will give you so many things. Okay, some of the people may not know about what are the different electrical quantities are there. Okay, I will tell you one by one. Okay, so first one is current. Okay, so current is the electrical quantity, so that we have to measure that. Okay, and similarly voltage, we have to measure the voltage. I'm calling the name measure. Okay, measure, we have to measure. Okay, and similarly power we have to measure, and similarly energy we have to measure. Okay, so we need to just check, okay, what is the energy, and similarly resistance we need to check. What is the resistance of your wire? Okay, so this wire, what is the resistance? We need to check that one also. Okay, see, in this class what we are going to learn means, okay, in measurements class especially, we will be learning about all these measurements. Okay, resistance, not only resistance, okay, inductance, capacitance, q factor, d factor, and how we will measure all these things. So there will be certain instruments, right? Okay, so if you want, you can respond in the chat box. Okay, so there will be chat box. Whenever you get doubt, or if you want to ask me something, or if you want to reply me, so you can immediately just open the chat box and message. Okay, so there is, it's a live class, right? Okay, whenever you get some doubt, immediately you can just message in that. I will be continuously monitoring, okay, your messages only. Okay, so for me, what is important means, you need to understand the subject, then only so you can able to perform well. Okay, so that's what important for us. That's why I will be always monitoring the message box. Okay, now see, someone replied there, voice is very low sometime before, so I just increased my voice. Okay, so like that, if we can't understand some topic, that topic also I can just repeat. Okay, so that's what. And to measure all these things, there should be what instruments we need. Okay, instruments. See, some of you people know about some of the instruments. What are the instruments we have? Those all instruments we need to design. Okay, we need to design. In this subject, what we need to do is we need to design. Okay, so designing means, so tell me one thing, just like a scientist, okay, we don't have these ammeters, voltmeters, or wattmeters, or any other thing before some years. So what we need to do in this session is how this instrument is working. Okay. So designing means we are not inventing anything new. Whatever someone already invented. Okay. So they have discovered something. Okay. So what we need to do? We need to just find out the working principle. How this is working. Okay. So what is the principle behind this one, and how it is measuring something. Okay. These all things we will be learning in this one. Okay. So see one thing. So some of the details I will give. Okay, so current, what is the measurement? Voltage, what is the measurement? How you can, okay, so instruments you need to know. Okay, so about for all current measurement, what are the instruments we have? Okay, so these all things we need to know. Okay, see, some of you may know about this one. What is the instrument we use for the current measurement? If you know, you can respond in the chat box. Okay, so for the current measurement,
Meter.
yeah, what is the instrument we are using means, that's the ammeter. Okay, so I'm just representing like this only. Okay, so ammeter, I'm just mentioning like this. Okay, and similarly, so for the voltage measurement, what is the meter we are using means, that is the voltmeter. Okay, see, remember one thing, you don't, no need to get fear about some other subjects. Okay, like computer science people or computers people. Okay, no need to see these things as the different things. Okay, these are, we are discussing from the basic level, like whenever you see these things, okay, and you have to get those things, like that only we will be teaching these things. Okay, and never fear about these things. These are from electrical, we won't get. These are from electronics, we won't get. Okay, don't think like that. Everything, okay, even electrical people. So when you see the computers, okay, so computer subject, then you can able to get. Okay, so the lecturers will teach in that way in these sessions. Okay, so that's why these live sessions. Okay, and similarly for the power measurement, there will be watt meter. For the energy measurement, there will be energy meter. Okay, so energy meter. And similarly for the resistance measurement, for the inductance measurement, for the capacitance measurement, and all these things. Okay, so we have bridges. Okay, so bridges we will be discussing about all these things. Okay, bridges. Okay, so this is the brief syllabus. This is in electrical only, and similarly in electronic measurement, we will be knowing about mainly the CRO. Okay, CRO and multimeters also we will be learning. Okay, so many of you, so as you all people are working in BSNL, okay, so and some of you are just familiar about some of these instruments. Okay, so multimeter, many of you may know about this one. Okay, even some of you know about the operations also, but I will discuss everything. Okay, okay, so multimeter, we will know about these multimeters. And there are some digital instruments. Okay, so like electronic voltmeters are there. Okay, electronic voltmeters, then digital voltmeters. Okay, so these are all we are going to learn. Okay, so like in ammeter also, so you may get doubt immediately. Okay, current you are telling, which current it is, whether it is AC current or DC current. So these are basic things. Okay, you may know already, but otherwise I'm telling you. Okay, so there are two types of powers. One is AC power, another one is DC power. Okay, so in all our households, which powers we have means we have only AC power. Okay, so AC power, and all our loads are AC loads only. Okay, so in our household, but there will be different DC types, DC loads also. So once time comes, okay, you will understand about different types of loads also. Okay, so anyway, current, which measurement we have to do means we have to do AC current measurement, and similarly DC current measurement also. Okay, so there are different types of instruments we have. So first we will go through different types of instruments, then we can know about so what are the different types of instruments. Okay, so types of instruments we will learn first, so then we will be learning about so different instruments. Okay, so what are these indicating type of instrument, integrating type of instrument, recording type of instrument? Okay, these are three types of instruments. So what is the difference? Why I have categorized like this? Okay, that's what we have to know. Okay, so why we have categorized like this? So that means, for example, okay, so forget about the subject. If something is there like this, some some scale. Okay, so we will call this one as the scale. Okay, so we'll be having some scale. Okay, scale can be in either way. Okay, so either the scale is in the bottom or on the top like this. Okay, so scale is certain scale. Okay, so have you ever seen like this any scale? Any scale have you ever seen like this in some instrument when you are doing some graduation or any diploma in the labs? You might have observed some instrument, right? Okay, so this is some scale. So on the scale, there will be some readings. Okay, like this is 1, 2, 3, 4, 5, like this. Okay, so there will be some readings. So what happens means whenever you connect some pointer like this, okay, this is called pointer or needle. Okay, so this is called pointer and this is the scale. Okay, so whenever, for example, if you are measuring the current, then suddenly whenever you are measuring, okay, so I'm not telling you how you are measuring, later you will understand. Okay, how we are measuring. For example, if you are measuring current, if it is 2 amperes, okay, where the pointer need to stop, it has to move little bit like this in this direction, and the pointer need to stop here. Okay, understanding, right? The pointer need to stop here. Okay, so then only we can just confirm, okay, current value is 2 amperes. Understanding, right? The current value is 2 amperes. We can get like this now. Why we got the confirmation? Because the pointer stopped there. Okay, so what it is doing, it is indicating. Okay, so it is indicating. Okay, so whenever you see a scale and a pointer, okay, whenever you see a scale and a pointer, what is the type of instrument? What is the type of instrument? You can reply in chat box. Okay, so some of you people, so whether I have to know, okay, whether you are understanding or not. Okay, that's why I'm asking. You can reply in chat box. Okay, so we have to travel in some days. Okay, so more than some weeks. Okay, it is. So definitely, whenever you attend continuously to the classes, you can understand the complete things. Okay, so it's simple. Whenever a pointer is indicating on some scale, which type of instrument it is? Indicating type of instrument. Okay, it's one of the previous year question. Okay, so in BSNL only, so they have given so this model of question. Okay, so what is indicating type of instrument means? The instrument which indicates the value on a scale. That type of instrument is indicating type of instrument. Okay, see some of you have replied there. Okay, so it's so simple and you can reply, and whenever you get doubt also you can ask. Okay, and what is integration? Okay, so maybe some of you know about integration, but I will tell you what is integration. So whenever you are counting something, okay, so I'm counting something. After 1 minute, my count is 10. Okay, after 1 minute again I have started counting. Again, after 2 minutes, my count is 21. Okay, that means total how many I have counted? Total I have counted 21. Okay, so that means in first minute I have counted 10. In second minute I have counted 11. So total, okay, what is the difference? 11 only, right? Okay. So in second minute I have counted 11. So total we got as 21. Okay. So that means what we are doing for the 10, we are adding the 11, then only we are getting 21. This is simple calculation only. Okay. So not like I'm not teaching any plus and all these things. Additions we know actually. Okay. So, but what we are doing actually, for the previous value of 10, we are adding the 11. Then only we will get the 21. Understood, right? What we are doing, we are adding the previous value to the existing value. Again, one more minute I will add, I will get the count 10. Okay, so I will add this 9 to the 21. Then it will become 30. And again, next minute, I will add some value of 5. It will add to this 30. Then it will become 35. So what we are doing over a period, we are just adding. Okay, so adding means in a technical way, how we will be answering this? It's a integration. Okay, so we'll call as a integration. Okay, so what is integration? Integration means adding the values over a period. So that is called integration. Okay, so now you tell me. So everybody know about this energy meter, right? Energy meter are in front of our home. Okay, if you want after the class, you can observe in front of our home there will be energy meter. Okay, today we will consume 4 units. Okay, today we will consume 4 units. Tomorrow we will consume 5 units. Like that full month we will consume some units. Okay, and the end of the month, that person will come from the electricity board. Okay, so he will be giving a number of units. Okay, for the end of the day you have consumed 172 units. Understood, right? He will give like this. What he is doing, he will be adding the values to the previous one, adding the values to the previous one. Some instrument will do like this. Okay, so what is that instrument? Which type of that instrument means? That is integrating type of instrument. Are you understanding? Just reply sometime. Reply someone. Are you
Yes, sir.
understanding what I am
Yes, sir.
explaining here? Yeah, okay, so that's good. Okay, so because I need to know it's online, right? Okay, so I cannot observe someone's whether they are someone's face, and that's why I just need some response. Okay, yeah, okay, understanding, like that's good. Okay, So we are adding the value to the previous value. So that's called integration. Okay. So what is the example? Can anyone give? Can anybody give? What is the example for integrating type of instrument? I want example. Example I want. Okay. Integration. Okay. Real time example I want. Integrating type of instrument. What is the example?
Odometer.
Yeah, odometer. Okay, so maybe some of the people don't know about odometer. Simply, I have only explained just now. Energy meter, you know, right? Energy meter already. So that is a perfect example. Yeah, that's what. Okay, Mohammed. Energy meter. This is perfect example. And like this, so many are there. Okay, so many meters are there. Anyway, in our syllabus, yeah, TOD. That's also there. Okay. So anyway, energy meter is the integrating type of instrument. Okay, so we will discuss about this energy meter whenever we start energy meter concept. Okay, so and the third type of instruments what we have, recording type of instrument. Okay, now you might have know about this one, but I will give you example first, then you can understand. Okay, so maybe in movies or in the hospitals you might have observed, so the heart rate we will be seeing like this. Okay, so ups and down like this, so up and down like this. Have you ever observed like this? Uh, have you ever observed? Oh, that's not right. Okay, someone is just answering in the chat box. Okay, so have you ever observed like this? What is that meter? What is that meter? ECG. Is that no? ECG. Understanding right? It's ECG. ECG means it's a cardiogram. Okay, electrocardiogram, cardiogram or cardiograph, anything. Okay. So this cardiograph or cardiogram, okay, what it will do? It will record the signals. What signals it will record? It will record the heart signals. Okay. Over a period, it will record. I'm calling record. You see, it has to record and it has to be on the screen like that only. Anyway,
Sir, can't able to hear.
Sir, your voice not getting.
Your voice not coming, sir. Hello, sir. Your voice not coming.
sorry, is it okay now?
Okay, sir.
Okay, okay. So actually,
It's okay now. It's okay now.
yeah, okay, okay. Thank you, sir.
But
Thank you. Okay. So actually, problem is when I'm teaching here, if anybody else turn on the audio, my audio may turn off. Okay. So that's what the problem. Please, everybody, turn off their this thing audio. Then it will be smooth. Okay, so you can understand properly all these things. Got it? Got it right, everyone? Yeah, that's okay. Now okay. Audio is okay now. Okay. So now you know whenever we get the straight line like this, it's not like the person is dead. Okay. We have to call that instrument is showing this one means we have to call the doctor. And doctor will make like this. Okay. He has to do something if possible. And maybe some oxygen problem is there, like different application, right? Okay. So what it has to do is it has to record. And again, this straight line will become like this one again because there may be some problem. Okay, and to understand all this, whether the heart signals are working or not, the instrument need to work properly. Okay, that's why it has to record the signals over a period like this. Okay, so we might have seen, okay, so many, even in the movies, in the hospitals, not only in the heart signals, okay, brain signals also we can record, or any muscle signals also we can record, pulse also we can record. Like this, so many instruments out there, okay. And this type of instruments, what we call this type of instruments, that is recording type of instrument. Okay, recording type of instrument. These are the three types of instruments we have in our electrical and electronic measurements. Okay, so whatever instruments we are just studying here, those are all instruments belongs to this indicating type, or integrating type, or recording type. Okay, only these three types of instruments we need to study. And indicating type of instruments, we have ammeter examples. Okay, ammeter, analog ammeter, analog voltmeter, analog wattmeter. We have some more instruments like that. Okay, and for the integrating type, what is the example means, we know already, it's an energy meter. Okay, and for the recording type, what is the example means, that is ECG. Okay, and not only ECG, we have CRO, right? Yes or no? CRO is also recording some signals or not? Yes or no? Someone just answer in the chat box. It's a recording type only, right? CRO, cathode ray oscilloscope. Okay, cathode ray oscilloscope. Okay, in our sessions, we will be learning about this cathode ray oscilloscope also. Okay, so and these are all about so the types of instruments. Okay, now we will start with some instrument. Okay, so what is the instrument name? That is PMMC. Okay, PMMC means permanent coil moving permanent magnet moving coil instrument. Okay, you see, permanent magnet moving coil type of instrument. Okay, so before learning about this one, I want to give you basic analysis about the ammeter and voltmeter. Okay, ammeter and voltmeter, we have to know some basic points about these things. Okay, so what are the basic points means, where we have to connect the ammeter. Okay, where we have to connect the ammeter, and similarly where we have to connect this voltmeter. Okay, for example, one load is there. Okay, one load we have, and that load will definitely carry some current, right? Because it has some power supply. So load means definitely it will work with some power supply only. Okay, so whenever we have some power supply, then definitely inside there will be some current flow. Okay, so inside there will be some current flow. Whenever current flow is there, definitely across this load we will get some voltage. Okay, so now I want to know what is the current in this load. I want to know. So I can understand. Okay, I have to calculate, I have to know the current. So I have to connect this ammeter in this circuit. Where we have to connect this one, either in series or in parallel. Yes or no? We have only two types of connections. In series means the wire is the same wire. Okay, like this. Parallel means across. Okay, I will give as a different way. Okay, just see. Okay, so this is the load, and this is called series connection.
അതങ്ങനെ അയക്കുന്നില്ല അടിക്കുന്നില്ലല്ലോ.
And another one is for the load, if you connect like this, that is the parallel connection. Okay, now you tell me where we have to connect the ammeter. Okay, where we have to connect the ammeter. Okay, see, some of you may know answer. Okay, but I want to explain some more points about this one. See, current will flow in series only, right? Okay, so the current in the load current is flowing like this. the load current is going in this way, we have to calculate that current only. We have to check that current only. So through the meter, okay, through that meter, the same current need to flow. Then only that meter will indicate the same value of current. Okay, let's take some example, 5 amperes. Understanding, right? You have to calculate the current in this load. So we got the ammeter we have connected in this one. Understood, right? Connected in series in this one. Okay. So whenever you connected in series, so there will be same whatever current load is carrying, the same current we can just measure using the ammeter. Understanding, right? And similarly, if you want to check the voltage, where we have to connect? Where we have to connect? So the voltage, a voltmeter we have to connect, right? Where we have to connect the
Parallel.
voltmeter? We have to connect in across. Okay, so across the load we have to connect. Okay, so the voltmeter we have to connect across, otherwise parallel we can call as anything. Okay, across or parallel, anything is same only. Okay, so we have to connect ammeter in series and voltmeter across that. Okay, so this is basic circuit analysis only. So we need to understand. Okay, so what happens if you connect wrong? So that's what one of the previous year question. Okay, so in our exam only they have given one previous year question, that is what will happen whenever you connect ammeter across the load. Okay, so that's what they have asked. For a load, if you connect the ammeter, will it give the correct reading or wrong reading? I want to know only this one. Okay, so just give response whether it will read the correct value or wrong value. It will definitely give the wrong only, right? Why? Means we have not connected in series. We have not connected this one in series. So it will definitely give wrong reading. And generally, ammeter will have zero resistance or very minimum resistance. Understood, right? So ammeter internal resistance is very less. Okay, very less. Otherwise, zero resistance. Zero resistance means so where current wants to flow. Where the current wants to flow every time. Whenever one resistance is 1 ohm, another resistance is 10 ohms. Where the current wants to flow. According to circuit, okay. So current will flow, okay. So current will flow in the low level of low resistance only. Understood, right? Low resistance only. And already ammeter will have very less current, okay. Already ammeter will have very less current only. So less, not current, less resistance. Okay, less resistance we have. So what will be the current flowing in this one? Very high current. Okay, very high current will flow in this one. Okay, very high current will flow. That means this ammeter is having very less resistance. That's why very high current will flow. Because of very high current, what happens to this ammeter? That ammeter will immediately burn. Okay, so you know how it will burn? So not directly it will burn. Okay, first starts with some spark. Okay, first some spark will come. After that, some smoke will come. Okay, so next some fire will come. Okay, some fire will come. Next, so some blasting will come. Okay, so finally, what will happen? It will burn out. Okay, so that's one of the previous year question. Whenever ammeter, if you connect across that, okay, across the load. So remember one point, where you have to connect always ammeter. Ammeter we have to connect in series always. Okay, and voltmeter we have to connect across the load. Okay, so that means parallel. Okay, so that's how you have to understand. Okay. Okay, so this is what happens. Okay, so for the ammeter and voltmeter. Okay, so and we will see something. Okay, so for the PMMC instrument, how it will be measuring some current, or how it will be measuring the voltage. Okay, so you will be understanding. Okay, so I will tell you some operation. Okay, so how it will be operating. So we'll take one magnet. Okay, so we'll take one magnet. So what is a magnet means? You know, for any magnet there will be north pole and south pole also, right? Yes or no? For any magnet, so there will be
Yes.
some north pole and south pole. So without north pole and south pole, there will not be any magnet, right? Okay, so that's all you can understand. Okay, you'll see the north pole and south pole. One will be north and another one will be south. Always flux lines, flux. Okay, you know, flux means the magnetic field lines we will be calling. Okay, so always flux lines will flow from north to south. Okay, north to south. Okay, so remember this one. These are all some of the points. The point whatever I am giving, everything is one of the previous year bit only. Okay, we should not miss even a single thing. Okay, so always the flux lines will flow from north to south. Okay, so what I will do is, in this magnetic field between the north and south poles, I will give one wire. Okay, I will give one wire. What happens to this wire? What happens to this wire? There will be some flux. Flux will generally represent as phi. Okay, so this is flux symbol. Okay, flux. And what happens to this wire means, if you send any current in this one, okay, if you send any current in this one, what happens to this one means, it will experience some force. It will experience some force. Looks like unfamiliar, right? I will tell you one statement. Okay, just remember this one. Current carrying conductor, I will just show you. Okay, so where it is, current carrying conductor. Yes or no? Is it current carrying conductor or not? Current carrying conductor, if we send some current, it is current carrying conductor. Okay, current carrying conductor placed in magnetic field, placed in magnetic field, will experience some force. Understanding, right? Current carrying conductor placed in magnetic field will experience some force. What is that principle called? If anybody know, they can answer. Okay, so there is no need to worry. Okay, so if anybody knows, just they can answer. Current carrying conductor placed in magnetic field will experience some force. What is that principle means? It is Lorentz force law. Okay, so Lorentz force law. Understanding, right? So now we will use this principle to operate our PNNC type of instrument. Okay, so this is the wire. Okay, so this is the wire which is moving. Okay, which is experience some force. So what we will do, for that wire we will connect one spindle like this. Okay, which is like rod. Okay, I'm just showing other way. Just see here. This is the rod and wire is there on this one. Okay, so this is the wire I'm calling. This is the wire, and wire wants to move. Why wire wants to move? Because we have placed this wire in the magnetic field. Yes or no? We have placed the wire in magnetic field. So that's why, as we know Lorentz force law, what is this Lorentz force law? Current carrying conductor placed in magnetic field will experience some force. Because of that force, this wire wants to move. Whenever wire wants to move, then automatically this one, okay, the rod, whatever this rod I'm calling, okay, or we can call as spindle. Okay, this spindle will try to rotate. Okay, so rotate in some direction like this. It will try to rotate. Understanding, right? So whenever we place the wire in the magnetic field, and if we send some current into that, the spindle, okay, spindle we can call, otherwise the rod. Okay, so it will try to rotate. Okay, see the same thing only. We have almost completed. Okay, so what is this? We have almost completed. What is this instrument operation? Okay, you see, again I'm just giving in a simple way. So this is the So this is the spindle we have. Okay, spindle means rod. Okay, it is trying to rotate. Why? It is having the conductor on this one. Okay, it's conductor. Why conductor wants to rotate? Because it is placed in magnetic field, and in the magnetic field, so there is in the magnetic field current carrying conductor is there. That's why. Okay, and whenever it try to rotate, what we will do for this spindle? I will connect the needle. I will connect the needle, and that needle wants to rotate in this direction. Okay, then under that needle I will form the scale like this. Understanding, right? Under that needle I will make the scale like this. See, what is this instrument? What is this instrument? This is the PMMC type of instrument. The basic circuit diagram it is. Okay, so that means a magnet we are taking like this. And what is that magnet? Permanent magnet. If it is permanent magnet, okay, if it is permanent magnet, and if the wire is carrying some current, then definitely there will be some movement. Okay, so there will be some movement in the
Scene
needle. Whenever needle moves,
ஆமாடி
automatically it will show. Okay, so 1, 2, 3, 4, 5. Okay, so
ஓகே
it may not be 5. Okay, so it will be more than 10 sometimes. It depends upon which type of instrument it is. Okay, later we will be understanding more. Okay, so whenever needle rotates like this, then it will show some value. So whatever current you are sending, whatever current we are sending inside, because of that current we are just getting the deflection here. Okay, so deflection here. So what is the current? If I send 5 amperes of current, tell me where the needle will stop. Now answer everyone. If you send 5 amperes of current, where the needle need to stop? Where the needle need to stop? If you send 5 amperes of current, where the needle will stop? It will definitely need to stop at where it need to stop. Answer, someone answer. Where it need to stop? It need to stop at definitely at 5
5.
amperes only. It should not stop at 4, right? If it will stop at 4 only, then it is wrong instrument. Okay, it has to stop at 5 amperes. So we need to design like that. Okay, we need to design. As this is the end point of this scale, I have given only 1 to 5 only. Okay, that's why 5 is the end point. We can call this 5 as a full scale deflection. That's what. Okay, someone given in the chat box. Okay, so this is called a full scale deflection. What is full scale? Full scale means the last value, whatever it is, that is full scale value or full scale deflection, we can understand. Okay, so you see this is the permanent magnet. Okay, so moving coil instrument. Why we are calling this one as a moving coil? Because the wire is moving here. We can use wire, otherwise coil also. There is no problem. Okay, so there is coil or wire, anything we can use. Okay, understanding, right? So this is what about the basic principle of permanent coil, moving coil instrument. Otherwise we can call as permanent magnet moving coil instrument, basically known as, okay, the PMMC type of instrument. Okay, this is the first type of instrument we supposed to learn. Okay, so in every instrument, you see, I have told one thing, only one thing I have told. So this pointer need to move like this to indicate the value under this scale. Okay, under this scale, the pointer need to indicate the value. Okay, indicate the value. But you see something, if I send 1 ampere of current, then it has to stop at 1 ampere, but less force. If you want, if you send 1 ampere, less force. If you send 5 amperes, okay, 5 amperes, more force. Yes or no? If you send 1 ampere, less force. If you send 5 amperes, more force. That means if I send 1 amperes, slowly it will go to the maximum value. Are you understanding? There is no opposition for this one. No opposition. Okay, nothing is stopping this pointer. So what will happen if I send 1 ampere of current? It has to stop at 1 ampere only. But what it will do? It will not stop with that small force. It will slowly go to the maximum value, whatever full scale value. It will go there. Understanding, right? There is nothing. No opposition is there. If nobody wants to stop, okay, then why it will not go to the maximum value? It will stop at a maximum value only. Understanding, right? So if I send 5 amperes of current, more current, okay, so more force. More current means more force. Okay, yeah, I will tell you, Ramya. Okay, so why damping needed? Okay, why controlling needed? I will tell you all these things. Okay. So Ratila Raj, okay, so I will tell you all these things, okay. See, in detail we have to learn. Understanding, right? So we have to send more current means if we send more current, more force will be there. Then with that force, fast it will go to the other side, okay. Fast it will go to the maximum value. So what you need to do is you have to provide, like however you are sending some current, because of that current you are getting some deflection. Okay, we are getting some deflection. So that is a deflecting torque we will call. Okay, so deflecting torque or operating torque we can call. Okay, and not only that, okay, so we have to provide one more torque. What is the torque? In opposition to the actual operating torque or deflecting torque, we have to provide opposition torque in this direction. What is the torque called? See, some of the people just answered right. Okay, so that is called controlling torque. Understood, right? Controlling torque. Okay, so we have to provide two torques at the beginning. Okay, so two torques we have to provide. Understanding, right? So whenever two torques we have provided, so then what more you need to do is just think once. So on the same thing only, on the same needle. Okay, so I will give you the same thing again. So this is the needle. One force in this direction. Okay, so I'm calling this one as deflecting torque, and another one is in this direction. Okay, that is controlling torque. Okay, so what happens? This needle need to stop. This needle need to stop. When it will stop? Whenever these two torques are equal, then only it will stop or not. Okay, so class will send in WhatsApp. Okay, so class will not send to WhatsApp. Okay, so it will send to the different application. You can open. Okay, so later you can contact and we will provide all the class.
Sir, the actual class will be in a different application, sir. Okay, sir. Actual class will be in a different application. This is an introductory class only. So that's why we are chosen the Google. Okay, sir.
Yeah, okay, understood, right. This
Okay,
is
sir.
just a demo class, okay. So the classes will be in a, if you miss the class, okay. So even there is provision for us. You can get, you can open the next day. Like today evening, the class is going on. If you can't attend the class or if you miss some of the portion of the class, then you can get it by tomorrow, okay. So whenever you get time, at the time, you can open that in the provided application and you can watch all the class and you can understand all the points, okay. Like the same class will be recorded and will be put in the application by tomorrow, okay. So that's what, okay. So no need to worry about losing any of the class, every class, okay, so you can able to access, okay. And coming to class, okay, so there are two torques we have discussed, one force in this direction, one force in this direction, definitely. So both need to be equal, then only it will stop, right? For example, this deflecting torque TD is greater than TC, then what will happen? This pointer will move in this direction. Okay. So if the TC, okay, so if the TC controlling torque is greater than TD, what will happen? This one, okay, so the needle will deflect in this direction. Okay, so needle will deflect in this direction. Understanding, right? So, but if we are sending 5 amperes of current, it has to stop at 5 ampere of current. We don't want a movement of, okay, we don't want a movement of this needle. It has to stop. We have to see the reading means it has to stop. How it will stop? Okay, so how it will stop? It will automatically it will automatically stop after 5 seconds or after 10 seconds. But you see one thing, whenever TD is equals to TC, then only it will stop, right? For example, we have made, okay, so now we have made TD is equals to TC. Understanding, right? Now we have made this one. What will happen? Now perfectly the pointer will stop. Okay, so see one thing. So these are all very important points. Okay, these things only in the exam they will concentrate more. Okay, so whenever you make this one already, the needle is here. You have made this side force is equals to this side force. So automatically the pointer will stop at 5 amperes. Now we are sending 5 amperes. That's why I'm taking as 5 amperes reading. Okay, but you see one thing. Okay, it's just the physics, right? On this pointer, one force in one direction, another force in another direction, both have same same magnitude, okay, same force, same value of force. So what will happen means this pointer will vibrate like this. Okay, so this pointer will vibrate like this, like here only. Okay, so around 5 amperes it will be vibrating like this. How it will means, okay, 4.8, 5.2, 4.8, 5.2, 4.8, 5.2, 4.8, continuously it will be moving like this. Can you understand this point? So what is happening to this pointer? Two forces are there. That's why this pointer is continuously moving like this. Okay, 4.8, 5.2. After like 10 minutes, okay, it will settle down at 5 amperes. We don't want, okay, 10 minutes. Who will wait there, right? Are you understanding? Nobody will wait to read only one value, to observe only one value. We have to wait for 10 minutes means it is wrong. Okay. Instrument, whenever you connect the instrument, immediately we have to get the reading. Okay. So that's why what we have to do, these oscillations we have to decrease. These oscillations you have to decrease. How you can decrease the oscillations means we need one more torque. What is the torque means? Damping torque. Damping torque means it is just reduces the oscillations. So that's what, right? Just tell me, have you understood there is a requirement of some damping torque in the instruments? Just someone just answer. We definitely need the damping torque or not? Yes or no? We definitely need some damping torque or not? We have to read the value perfectly. That's why we need damping torque. Now see this answer. Okay, if you give the answer properly now, then I can understand. Okay, so whether you have understood or not. Okay, now in total for any instrument, how many torques are required? Tell me. So you have to answer. Okay, in the chat box. For any instrument, how many torques are required? Uh,
3.
How many? Yeah, that's what. Okay. How many talks are required? Everyone. Okay. If you have understood, just answer. So it will be great response. Okay. If you give properly, 3 talks are required. And I'm not telling any lie. Okay. So this is one of the previous year question. Okay. And whoever, like, some of the people will definitely answer like only 2. Yes or no? Maybe. So some of you might have thought, okay, so for every instrument, 2 torques only required. One is deflecting, another one is controlling. Some of you may know like this before, but you see, correct answer is 3 torques are required. First one is deflecting torque, second one is controlling torque, and the third one is damping torque. Okay, don't forget about this damping torque. Okay, I will tell you use of each and everything. Okay, so why we need deflecting torque? To deflect the pointer. Okay, so see the reasons. Okay, so reasons, and we have to give all these reasons, and these are so important. Okay? That's why I just want to give again. Okay, see, first torque is deflecting torque. Okay, so deflecting torque, what is the use of this deflecting torque? It will deflects the pointer. Yes or no? Deflects the pointer. Deflects pointer. Okay, and the second one is controlling torque. What is the use of this controlling torque? It will stop the pointer. Yes or no? It will stop pointer. Okay, and another one is damping torque. What is the use of this damping torque? It will it will reduces the oscillations. Okay, so it will reduces the oscillations. Reduces the oscillations in pointer. Okay, oscillations in pointer. Okay, so like that we can understand it. 3 torques and why we required. Okay, so deflecting torque is for to deflect the pointer, controlling torque is for controlling the pointer or stop the pointer, and another one is to reduce the oscillations. Okay, so is there any voice breaking now? Just tell me, is there any voice breaking? No, right?
Oh,
Okay. So maybe it's check your connection also sometimes. Okay, so that's good. And how we are providing, now we have just understood about what is the use of that torques. Now how you are providing this torque, this deflecting torque, how you are providing? We are sending current into the instrument. Yes or no? We are sending current into the instrument or not? So because of this current, we are getting
Yes.
the deflecting torque. Now, how we are getting the controlling torque? We have to use some medium here. Okay, so controlling mechanism we have to use. I have not explained about this one. I will tell you. Okay, so controlling mechanism. Okay, so I'm just giving as a mechanism. Okay, controlling mechanism. So what are the different types of mechanism? Means there is a spring control. Okay, so spring control mechanism is there, and similarly gravity control also we have. Okay, so gravity control. See, in majority of the instruments we are using a spring control mechanism. Okay, in majority of the instruments we are using spring control mechanism. Okay, and I will tell you, we will discuss. Okay, whenever subject starts, okay, at that time we will discuss in deep about this spring control and gravity control also. And similarly, this damping, how you need to provide, you have to use some damping mechanism. Okay, we have to discuss. Okay, so damping mechanism. Okay, so damping mechanisms are generally 3 types we have. So one is eddy current damping. Okay, so eddy current damping, and second one is air friction damping. Okay, so air friction damping, and the third one is okay, so fluid friction damping. Okay, so fluid friction damping. Okay, so like that all 3 types of dampings are there. Now in the PMMC type of instrument, generally we will use eddy current damping. Okay, so why we have to use only this type of questions we will see in the actual sessions also. Okay, so these are the 3 different types of torques we have. Okay, so you can observe this one. So operating torques in any instrument. Okay, so the first one is deflecting torque. Instead of operating torque we can call as a deflecting torque. Okay, so deflecting torque. Okay, see, remember one thing, in the class only you have to get the clarity about all the questions. So that's how we will be teaching. Okay, so whenever it's not like you will be reading today and after 2 days I will revise again. So you can revise whenever you get doubt, you can revise, but you see the timing. Okay, we have very less time. In the class only we have to get more clarity. Okay, that's why whenever you get doubt, immediately you can even ask me. Okay, so not only me, whoever teaching here, you can ask immediately and we will clear all these things. Okay, and of course many of you are working, right? Okay, so there will be very less time for us for the preparation. So in the class, attend the classes properly. It's like every day whenever the schedule is there. Okay, so attend the classes. Unfortunately, if you miss the class, then you can open in the next day. Okay, so in the app. Okay, so deflecting torque, and second one is controlling torque, and third one is damping torque. Shall I ask one question, one important question that they are asking in the exam? So the question is, so for the proper instrument current measurement, okay, for the proper current measurement, okay, so proper current measurement, so which 2 torques need to equal? Okay, so which 2 torques need to equal? Okay, so remember the question. Okay, I'm not writing the full question. For the proper instrument current measurement, which two torques need to equal? I am writing TC equal to, okay, TD. Second option, TD is equals to TD. TD means damping torque, okay. So third option, TC is equals to TD, okay. And fourth option, TD plus TC is equals to TC, TD, okay. Okay, now tell me which option is correct. Just answer which option is correct. Okay, which option is correct? Please, everyone. Okay, if you can't understand, just ask me. No problem. Okay, which option is correct? Option.
into TC.
Yeah, that's what. Okay, so option one is correct. Okay, so you see, this is very simple question. But remember one thing. Okay, we have learned about this PMMC, right? Okay, we have learned about this PMMC. That's why we can answer this one. Okay, so about what is the operation and all. So we have learned. That's why we can just answer this very simple, and we won't even think in the exam. Okay, so directly we can just answer. Okay, so this is the one. Okay, now some more things. Okay, so like I will give you, as it is a demo class. Okay, I'm not giving the complete ones. Okay, so like in detail there will be so many things we have to learn. So but I will give you all those things. Okay, just a second. So this is only the operating parts. Okay, so I will ask you some more things. Okay, just see. Um, not only for the PMMC. Okay, so not only for the PMMC, even for the moving iron type of instrument, and I will give you some of the other instruments also as the bits. Okay, so you can just note down, or it will be useful for you. Okay, so for the PMMC type of instrument, how many torques are required? Means 3 torques are required. Okay, 3 torques are required. For moving iron type of instrument, also 3 torques are required. Okay, for the dynamometer type of instrument. Okay, so dynamometer type of instrument, also how many types of torques are required? 3 torques are required. Okay, and similarly we have so many instruments. Okay, but I'm just giving some. Okay, whatever required for our exam, some I'm giving. Okay, so using PMMC type of instrument, we can measure AC power or AC current or DC current. So if anybody know, you can just answer. Okay, so using PMMC type of instrument, you can measure only DC. Okay, so this is one of the very important bit. Okay, DC. Okay, only DC. Okay, we cannot measure the AC. Okay, we cannot measure the AC. Why? Means whenever you connect AC, okay, so the meter will damage. Okay, so PMMC instrument, whenever you connect, okay, so the meter will damage. Okay, so I will explain how the meter will damage also. Okay, so PMMC instrument, why it will not work for AC. Understanding, right? See one thing, I will give you this point. Okay, so what happens when PMMC is connected with AC supply? Okay, so PMMC generally reads. Okay, PMMC generally reads DC value. That means average values it will read. Understanding, right? For example, if you take the AC supply. Okay, so this is the AC supply. Okay, generally it will be having some frequency. Okay, so frequency AC, right? It will be having some frequency. This is the maximum current IM, and this is the negative maximum minus IM. Okay, so what is the average value? So average value of AC, perfect AC, right? It is sinusoidal AC. So average value is equals to 0. Okay, average value equal to 0. Think about the instrument. Okay, so instrument, for the instrument, the needle is here. The needle is here. This is 0 and this is 10 amperes. Maximum is 10 amperes. Just for example. Okay, see one thing, for this one, for the AC supply, from the 0 value to the maximum value, slowly magnitude is increasing, decreasing, negative maximum and again 0, and again positive maximum 0, positive maximum 0, like that. Okay, you understood, right? The magnitude of the current, it is increasing, decreasing, increasing, decreasing, increasing, decreasing. Yes or no? Understanding, right? So the magnitude, it will be increasing, decreasing, increasing, decreasing. So what this instrument will do, the needle, what it will do, it will go to the maximum 0, maximum 0, maximum 0, because the magnitude here, what it is doing, it is just changing continuously. The magnitude is continuously increasing and decreasing. So what this needle will do, needle will move to the maximum value and 0 value, maximum value and 0 value. But you see, what is the frequency we have? Frequency equal to 50 hertz. Yes or no? In India, we have the frequency of 50 hertz or not? 50 hertz means, you know, what is the time period? So time period means time to complete one full cycle. Okay, so that is nothing but a time period. Okay, so that means to complete this cycle from here to here. Okay, so that is the time period we will be calling. Okay, so generally time period is equals to 1 by frequency. Okay, so 1 by 50. Okay, if you calculate how much it will be, 1 by 50, 20 milliseconds. Okay, so 20 milliseconds it will be. Okay, that means the time period of a perfect AC sinusoidal, what it is? Perfect AC sinusoidal, what is the time period? It is 20 milliseconds. Okay, so that means in 20 millisecond, not even a single second, not even single second, within 20 milliseconds, it has to complete 50 times. How it's possible? You understanding, right? Within 20 milliseconds. Okay, time to complete one full cycle is nothing but time to complete one full cycle. Okay, so this is the full cycle from here to here. It is 20 milliseconds. Okay, in 1 second, how many cycles it will complete means 50 cycles will complete. Okay, 50 cycles. The same like for the instrument also, it is like 50 hertz if you are giving AC supply, if you are giving in 1 second. Okay, so in 1 second, this instrument needle, what it has to do, it has to go to the maximum and 0, maximum and 0. How many times? 50 times it has to go. Is this possible? Just think once. Is this possible? In 1 second, 50 times that needle has to go. You just do one thing. Okay, 50 times you just move your hand. Okay, in 1 second. Is it possible? Your hand only not possible. For that instrument, it is not even possible. So what it will do? The pointer will stay at 0 only. Okay, so stay at 0 only. But it wants to move, but it can't move. It wants to move, but it can't move. Why it can't move? Because time is very less. Okay, time is very less. Understanding, right? So time is very less. That's why it can't move. It will be at 0 position only. Only at 0 position means is it reading any value or is it not working? Answer. Whenever you give the AC supply to the PMMC type of instrument, is it working or not working? Is it working or not working? It's not working. Okay. So whenever it's not working, tell me one answer. For AC supply, this PMMC instrument is working or not working? Not working. Okay, so that's good. Okay, and not only not working. Okay, you know what this instrument will do? It will damage. Okay, it will damage immediately. So immediately means within it wants to move, but it can't move. It wants to move, it can't. What will happen? So there is some confusion for this. Okay, needle. So this needle produces more heat inside. Okay, so whatever moving system is there, on the moving system there will be more. Okay, so on the moving system more friction will come, so automatically meter will damage. Okay, so damage. If you connect for only 1 second, nothing will happen. If you connect for at least 10 seconds, meter will automatically damage. Now tell me, PMMC instrument will work for AC or DC? PMMC instrument will work for AC or DC? Only DC, okay? Remember, only DC. So this is one of the previous year bit. You take any exam, okay? In India, you take any exam wherever electrical subject is there, measurement subject is there, this question they will ask, okay? So that's all. Okay, understood, right? And similarly, moving iron type of instrument, I will give you some of the other instruments also. As it is a demo class only, I'm giving some more points. So just if you want, you can note it down, okay? PMMC instrument will work for only DC, okay? So moving iron type of instrument will work for both AC and DC. Okay, so both AC and DC. Okay, so now dynamometer type of instrument. Okay, so dynamo, these are all bits. Okay, if you want, you can. Okay, so if you want to give the answer also, you can just okay. So dynamometer. Okay, so dynamometer type of instrument, what it will read? It will read for both AC and DC. Okay, but both AC and DC. Okay, so that torque and all, okay, so we can discuss later, okay. So torque and all we can discuss, okay. Actually, reason is not torque, okay, it's because torque proportional to I square means, so torque proportional to I square, okay, somebody just told, okay, in the chat box. It's a non-linear, okay, so square is there, that's why it is non-linear, okay. So that's not the reason that it is it's not the reason that it is measuring for both, okay. Operating principle matters here, okay. For the PMMC, operating principle is Laurent force law, okay. For the moving iron, operating principle is electromagnetic induction, okay. So electromagnetic field you can call, okay. And for the dynamometer type of instrument, operating principle is induction principle, okay. So induction principle, or two torques are there, okay. So the same Laurent force law will work here also. Whenever we discuss about these all instruments, at that time we will be knowing, okay. So torque is always positive, then only we can get, okay. See, we always want positive deflection only, understood, right? Negative deflection we don't want, because for every instrument there will be some stoppers, yes or no? There will be some stoppers at the beginning, at the end, okay. So that's why negative deflection not possible for the indicating type of instruments. These are all some of the bits, okay. If you want, you can directly note it down, okay. So these are all some of the bits, okay. So for the indicating type of instruments, the negative deflection is almost we will not provide like that, okay, because there are some errors possible, okay. So that's why we can't, okay. Only positive side we will be preferring nowadays. Very olden days, okay, very olden days, when instruments are designing at that time, okay, so we will be having negative deflection also. But nowadays all advanced instruments having only positive deflection. Positive means this side, okay. Negative means this side. Negative deflection not possible because of stoppers. And there are some more reasons also. Later we will be discussing about those things, okay. And the next one more, you see, so this about the torques, linear scale or non-linear scale, we can discuss even at that time. So and later induction type of instrument, okay. So induction type, you tell me one thing, induction, how it is possible with DC? Is it possible induction? Induction type of, okay, so induction type of instruments, so will work only for what? Will work only for AC, okay. So by using this is all important bits, okay. Induction type of instruments will work only for AC, okay. So they won't work for DC, okay. So now electrostatic instruments will work for both AC and DC, okay. So and some more instruments are there, okay. Thermocouple type of instruments, okay. So thermocouple type of instruments will work for both AC and DC, okay. So both AC and DC, okay. So like that, understanding, right? So these are all important bits. And some more things also we can just write down. Okay, PMMC will reads average value only. Okay, so PMMC reads average value. Understood, right? Moving iron instrument. Okay, Sunil. Okay, so it's okay. Okay, later we can understand. Electrostatic instruments measures only voltage. Okay, so that's why it's correct only, but not a complete statement. So we can use the electrostatic instruments and measure the RMS value of current also. It's possible. Okay, we can learn in the class. RMS values, electrostatic instruments. Okay, I will give you one by one. Okay, so I will give you one by one. So the moving iron type of instrument, which type of reading they will give means RMS value they will read. Okay. And the dynamometer type of instruments will read RMS values. Okay. Induction type of instruments will read RMS values only. Thermocouple type of instruments will read RMS values only. Okay. So these are all important bits. Okay. So like this, once we discuss about all these instruments, then we can get even more clarity about this all. Okay. And one bit they have asked directly. Okay, so will the PMMC instrument reads RMS values? It won't read. Okay, any RMS values, only average value. Okay, so, and one more thing. Okay, so like these are instruments. What are those things? Whether can we design as ammeter or voltmeter? What it is? Okay, so what it is? Ammeter or voltmeter? What it is? That's what you have to know. Okay. So PMMC type of instrument, whether we have ammeter or voltmeter. So these are all important only. So PMMC, we have ammeter and voltmeter, both we have. Understood, right? And similarly, moving iron type of instrument, what we have? Ammeter we have and voltmeter we have. Okay. Tell me one thing. PMMC, do we have any PMMC wattmeters? Do we have any PMMC wattmeters? PMMC wattmeters? No wattmeters. Okay, PMMC, we don't have any wattmeters. Moving iron also, we don't have any wattmeters. Now tell me, dynamometer type of instrument. What are the things we have? Ammeter, voltmeter, or wattmeter, or any other things? Tell me, dynamometer type, what we have? Do we have ammeter? Yes. Voltmeter? Yes. Okay. So wattmeter? Yes, we have wattmeter also. Okay. So wattmeter also. Understanding, right? Not only wattmeter. Okay. So we have power factor meter also. See, many of you don't know these points. Okay. I'm just giving you. So power factor meter also we have. Okay. Power factor meter. So do you know about the power factor? This is the measurement of quality of power, quality of electrical power. Okay, all we can measure, but errors more. Okay, so all we can measure. Okay, so it's like what we can design. Okay, you understood? We have ammeters. Every instrument we can use as ammeter, but for the DC measurement we will use only PMMC. For AC measurement we will use only moving iron type of instrument. Okay, it's like that. Okay, it's not like errors. We don't like, we are not measuring today. We have to check the instruments in our subject. We have to check the instruments, whether errors are there or not, how errors are coming, why these errors are coming. We have to know all these things. Understanding, right? So we have to, we can design any instrument. Okay, dynamometer type of energy meter is also possible. Okay, energy meter also possible, but okay, so what we have energy meter, that we will be learning later. Okay, next, similarly, induction type, even in the watt meters, you know what are the different types of watt meters? MC type of watt meter is there. Okay, so LC type of watt meter is there, low power factor watt meter is there, and upper power factor watt meter is also there. Okay, so these are all different types of watt meters, and even in the power factors. Okay, so low power factor measurement, high power factor measurement, so many are there. Okay, so we can use this dynamometer type of instrument as this different type of instruments. Okay, now induction type also we have ammeter, voltmeter, wattmeter, energy meter, and we can even have the different type of power factor meters also. Okay, so that's what we can understand. Okay. Just 1 minute. Okay. Okay, and similarly thermocouple type. Okay, so thermocouple type also we have. So this thermocouple type of instruments we can operate as ammeter, voltmeter. Okay, so these are the famous things. Okay, so like ammeter, voltmeters are of thermocouple type. These are very famous ones. Okay, and comparing all these instruments, which instruments will give the perfect readings? Perfect readings means the instruments. Okay, so thermocouple type of instruments will give the perfect readings. Okay, so thermocouple types, but if particularly in the DC, okay, for the DC current measurement or DC voltage measurement, which instrument is perfect means PMMC is the perfect one, which is having least errors. Okay, errors in PMMC are very less when compared to any other type of instrument. Okay, there are many reasons. Okay, and thermocouple type of instruments are reading the values based on the temperature changes. Okay, so that's why thermocouple type of instruments are perfect instruments. Okay, so these are, yeah, PMMC more accuracy in DC. Okay, so that's correct only. Okay, but for all the instrument in a generalized way, which instruments will give the perfect readings with less errors means thermocouple type. And if you particularly ask about PMMC, that's a DC we have to. Okay, so DC if they ask, PMMC is the answer for us. Okay, shall we see some questions on previous year? Okay, how previous year questions they are asking? We remember one thing, for any exam, whatever exam you prepare, if you see the previous year questions, you will get to know the standard of the questions. Okay, standard of the question. Okay, so Wheatstone bridge method of resistance measurement is ideally suitable for measurement of resistance values in the range of, okay, in the range of what Wheatstone bridge they are asking. Okay, Wheatstone bridge, that means resistance. Okay, resistance measurement, resistance measurement. Okay, resistance measurement. So there are three types of resistances. Okay, so whenever resistance value is less than 1 ohm, so that is called low resistance. Okay, so this is called low resistance. Whenever resistance value is in terms of 100 ohms, okay, 100 ohms, so then that type is called 100 ohms means 100 to 100 to like 1000 or 10,000 like that. Okay, so this is called medium. Okay, so medium resistance. And more than 10k, greater than 10k, after that anything 100k and all, that is like high resistance. Understood, right? High resistance. Now there are different instruments. Okay, I will give you some of the values. Okay? See, knowing the answer not only important. Okay, so if they ask in this area any model of question, we have to answer. That is what our aim. Okay, so I will give you some things. Okay, for low resistance measurement. Okay, for low resistance measurement, the instrument what we are using, so for the instrument what we are using, the Kelvin's double bridge. Okay, so Kelvin's double bridge. Understood, right? Kelvin's double bridge. Okay, otherwise Kelvin's bridge in options. If Kelvin's bridge is there, you can use like that. Okay, so for a medium resistance measurement, okay, so for medium resistance measurement, so we have Wheatstone bridge. Okay, so whatever we have written here, so Wheatstone bridge. Okay, for the high resistance measurement, okay, for high resistance measurement, what we are using means Megger we are using. Okay, Megger we are using. Understanding, right? These are all the So basic things, okay, just basic things only. So what is the operation of Wheatstone bridge that we can learn in the subject? These are only the questions, okay. How the classes will be in order to understand, we are just giving, okay. So there will be proper questions we will be giving, all previous year questions. Question paper discussions, like these are all the questions they were giving in the exam, means we have to know all these things, okay. Without these things, we should not go to the exam, okay. So and if you three types of resistances are there, now they have mentioned Wheatstone bridge method, okay. Now tell me, medium resistance it is. What is the medium resistance range? It is in terms of 100 ohms or even 1 ohm is also okay. Whatever near to 100, this is all medium resistance only. But less than 1 ohm means that is low resistance, okay. Like 1 ohm to 10 kilo ohms or even 20 kilo ohms also, it is like the medium resistance only, okay. So tell me, what is the answer for this question? Answer for this question. Answer for this question. Okay, so we can use even for the B or C also we can use, but the perfect one we can get as B only here. Okay, because 10K we may consider as, okay, so greater than 10K means it is 10K. Okay, we can use as high resistance. Okay, so that's why, okay, we can use 0.1 ohm to 200 ohm. But you may get one doubt. 0.1 is there, it is less than, right? Less than 1. Let me give you, okay. Sunil, just let me give you, okay. See, many people are answering B. That's why I'm just explaining first, okay. So 0.1 is there. Once 0.1 means, can we measure using Wheatstone bridge? We cannot measure, right? 0.1 ohm means we cannot measure. That's what I just mentioning, okay. 0.1 ohm means we cannot measure using Wheatstone bridge. What we have to use? Kelvin's double bridge for that. So perfect answer for this one, what? Second option or third option? B or C? Tell me, B or C. What is the correct answer for this one? What is the correct answer? Please answer, everyone, okay. C only, okay. So only C is the correct answer for this. Understanding, right? C. Because for example, if the option is like this, 1 ohm to 200 ohms. Now tell me, is this correct or not? Can we use Wheatstone bridge? For 1 ohm to 200 ohm, can we use Wheatstone bridge? From 1 ohm to 200 ohms, can we use the Wheatstone bridge? We can use, there is no problem. Understanding, right? So you have to get the clarity about this, okay? And one more, okay? So there are more instruments, okay. So more instruments, more bridges also there, okay. We will discuss whenever it's required, okay. And the next we will see one more, okay. What happens if a voltmeter is connected like an ammeter in series to the load? You see, we have studied the different case before. Now we have to connect the voltmeter like ammeter. Previously we have connected ammeter like voltmeter. Now we have to connect the voltmeter like ammeter. Okay, so voltmeter we have to connect like ammeter. So generally, if voltmeter is not present, okay, so if voltmeter is not present, then current flowing is 10 amperes, for example. Okay, so 10 amperes in this one. Okay, so whenever you connect some source, okay, let's take as DC only. 10 amperes current is going. Now, whenever you connect some voltmeter in this one, generally voltmeter is having high resistance. Voltmeter internal resistance is very high, almost greater than 10K. Okay, so that is the high resistance. Okay, greater than 10K. In terms of 10K or 20K or even 1 mega ohm also it is possible. Okay, kilo ohms. Okay, or in mega ohms. Understanding, right? So whenever voltmeter is having very high resistance, can the 10 ampere can flow through this circuit, or almost zero current will flow? This is very high current, okay, high resistance, okay, high resistance. Whenever high resistance means low current. Understood, right? low current. Okay, high resistance means low current. Now you choose the option. Which option is correct for this one? Which option is correct for this one? Option D is the correct one. Okay, so you see the meter will burn. Will the meter burn in this case? In the meter there is no current, okay, or very less current, so nothing will happen to the meter. Understanding, right? Nothing will happen to the meter. Now second option, you see the measurement will be too high. No measurement, zero measurement here. Okay, the measurement here it will be zero or very less current it will show, or very less voltage it will show. Okay, an abrupt high current will flow. No high current, already zero current. Okay, so fourth option, there will be almost no current in the circuit. Okay, so no current in the circuit. Option D is the correct option for us. Okay, correct answer. Understood, right? So the next question we will see. Okay, which of the following meter is most suitable for measuring radio frequency currents? Okay, radio frequency currents. Okay, confused anything? Srini, just answer something. What confusion? If ammeter is used as a voltmeter, then okay, so ammeter I have explained right at the beginning only. If ammeter, if we connect, okay, so if the ammeter, okay, so generally we have to connect the ammeter in series with the load like this. Okay, if you connect across that load, okay, that we have already discussed now in the at the beginning of the session. Okay, so if ammeter, if you connect across the load, what will happen? This ammeter, more current it will take, and this will blast. Okay, this will burn out. Understanding, right? This will burn out whenever you connect ammeter like voltmeter. Understood, right? And the next one is, which of the following meter is most suitable for measuring radio frequency currents? Okay, so answer for this one. Okay, so we need to see answer for this. See, whenever frequency is more, what we have to think is, because of frequency, which instrument is having less error? That instrument we have to choose. Understood, right? Whenever frequency is more, high frequency, radio frequency means it will be in terms of kilohertz and megahertz. Okay, so if it is FM frequency, it will be in terms of megahertz also. So that's why whenever frequency is more, you tell me, can we use moving coil meter? Answer these questions. Okay, more than this question I will teach you more. Okay, just see, can we use moving coil instrument to measure the radio frequency currents? Can we use moving coil meter? Why we can't use? Why we can't use this one? Because PMMC is only for DC, right? Something they are mentioning as frequency means that is AC. Understanding, right? Everybody is understanding, huh? Frequency equal to 0. Okay, that's okay. PMMC is only for DC. Okay, and moving iron meter. Can we use moving iron meter? Can we use moving iron meter for measurement of this? We can use, but more error. PMMC reads only DC values. Okay, no AC. PMMC does not work for AC. Okay, it will work for only DC. Okay, PMMC or moving coil instrument work for only DC. Moving iron meter. Okay, moving iron meter we can use, but more errors. Okay, so more errors will come, because in moving iron, which type of magnetic field is there means weak magnetic field is there. Okay, so weak magnetic field is there. Okay, so weak magnetic field is there. That's why moving iron type of instrument will have more errors. Okay, moving iron type of instrument will have more frequency type of errors. Okay, what are those frequency type of errors means? Eddy current error. Okay, so eddy current error and hysteresis error. Okay, these are the two frequency errors, and moreover, not only those, moving iron instrument. You know one of the statement about moving iron type of instrument. Moving iron type of instrument perfectly reads the values and perfectly reads wrong values. Understanding, right? Moving iron type of instrument perfectly works for both AC and DC and perfectly reads wrong values. Understanding, right? So that's what moving iron type of instrument. Okay. Next, thermocouple meter. Okay, so thermocouple meter also we can use. Okay, thermocouple type meter also we can use. And I told you before sometime, thermocouple type of instruments having very less errors. Okay, and the frequency error is almost zero for the thermocouple type of instruments. Okay, so that's why for the high frequency, or for the radio frequency currents, what is the instruments we can use? Induction type of instrument. No, not that. Okay, what's that? Thermocouple type of instrument we can use. Understanding, right? Now induction type of instruments. Okay, so induction type of instrument we can use, but more errors. Okay, more error. Induction type also. Okay, because induction principle itself is having a magnetic field. Okay, so wherever magnetic field is there, there will be some leakage flux. Some of the flux lines will go in different way. Okay, so that's why there will be more errors, and the frequency error is also present in that one. Okay, so that's how you can understand. Okay, this is about what is the answer for this question. For radio frequency currents, or for the very high frequency currents, thermocouple type of instrument, or thermocouple meter we have to use. Understanding, right? So okay, shall we next question? Okay, next we don't have. I will give you some more questions for you. Okay, I will give you some more questions for you. Okay, are you understanding or not? Just answer someone. Is this okay? Is this okay? Are you understanding or not? Just answer someone. Okay. See, in electrical, okay, so whatever branch you are electrical or electronics, or even the computer science, okay, so computers. So the basic things if you learn, okay, so remember something, the basic things if you learn, then everything will come for us. Okay. So nothing to worry, okay. So in our exam, simple logic, okay. In our exam, all three branches are there means definitely electrical people don't know about some of the computers, okay. So that's why they will concentrate the basic points, okay. So what whenever you are preparing at that time, the basics you have to be more like more strong, okay. The basics you have to be more strong. Understood, right? Whenever the basics are so strong, then automatically you will get the answers. All these, okay, whatever questions I have given here, these are all questions, the basic questions only. Okay, so they can't go even more deeper also. Understanding, right? So this is how. Okay, and more things like for the voltmeter and ammeter. Okay, just think once, what is the internal resistance of ammeter? Okay, if you want to know. Okay, for the ammeter and voltmeter, what are the internal resistances? We have to learn these points. Okay, I will tell you. So for example, if we have a load, okay, so if we have a load like this, a voltmeter is there. Okay, so what should be the internal resistance of voltmeter? What should be the voltmeter? Okay, I'm asking about voltmeter first. Okay, so voltmeter, what is the internal resistance? You remember, this is our fan. Okay, so this load is nothing but our fan. So fan need to get some current or not? So fixed current it has to get generally. For example, this voltmeter is having a low resistance. Example only. Okay, example. This voltmeter is having a low resistance. Whenever it has low resistance, what happens? all the current will go through the load or your voltmeter? Where it will go, all the current? Load or voltmeter, where it will go? Tell me where it will go, all the current. All the current will go through the voltmeter only. That means, will the load works properly? Will the load works properly? Will the load works properly? It won't work. Okay, load not works properly. That means whatever fan application we are using, whatever AC we are using, okay, whatever TV we are using will experience low power. Okay, low power or low current we can call. Okay, so that means whenever low current means load will not work properly. So because of your instrument, because of you are connecting the voltmeter here, which is having low resistance. This load is not working properly. We are disturbing the load by connecting the voltmeter, which is having low resistance. We should not connect like this. That's why whenever you connect the ammeter, will the load work properly? It is having, generally ammeter is having low resistance. That's why all the current will go through this ammeter only, and ammeter will blast. Understanding, right? So we have already understood that point. Okay, so whenever ammeter, if you connect across that, it's almost like short circuit only. Okay, whenever ammeter, if you connect across the load, it's almost short circuit only. Okay, this is what. Okay, and that's why voltmeter should not have low resistance. The internal resistance of voltmeter, okay, so internal resistances we are fine. We are just calculating, or we can call as, okay, so internal resistance, otherwise the operating resistance of voltmeter, anything we can call. Okay, so tell me, generally for the voltmeter, what should be the internal resistance? It will be very high value or very low value? Very high value. Okay, so for the voltmeter, very high. Okay, for the ideal voltmeter, what is the internal resistance? What is the internal resistance? Very high value. What is a very high value? Infinity. Okay, so infinity. Understood, right? And similarly for the ammeter, okay, for the ammeter, how will be the internal resistance? Ammeter, okay, where we have to connect ammeter? In series with load. Okay, ammeter should be connected in series with the load. Okay, so that's why, so very low. Okay, so generally we have to give as practical ammeter only, so as minimum as possible, otherwise minimum we can give. Okay, minimum resistance. Okay, so now ideal. Okay, so ideal ammeter, what is internal resistance? It is 0. Okay, these are all the bits they have given already. Okay, so if you have question papers and all, okay, you can just check. Otherwise in the internet you just check whether the points we are just covering or not. Okay, so like this is the way we have to learn the subject. Okay, subject we have to learn from the basic point of view. Okay, so then only we can able to answer. Understanding, right? Okay, so that is the ammeter. Okay, and remember one thing, and I will give you the generalized answer. Okay, whatever we are connecting in series, it should have less resistance. Remember this point. Okay, whatever we are connecting in series, it should have which resistance? Low or high? Low resistance. Okay, so whatever we are connecting, it should have low resistance. In series, whatever you are connecting, it should have low resistance. Whenever you are connecting something in parallel, it should have which resistance? High resistance. Understood, right? High resistance. Okay. Is it clear? Is it clear? Just answer everyone. Have you understood the points, whatever we have discussed? Just answer everyone, just answer. Just answer everyone. Is it clear whatever we have discussed now? Okay, it's like we have to connect the voltmeter and ammeters in a proper way. Okay, so otherwise it's not possible. Okay, now I will give you one connection. Okay, so you have to tell whether that is which connection of wattmeter. Okay, so just simple things. Okay, okay, it's not so difficult. I will give you in a simple way. You just answer that one. Okay, so generally wattmeter is having how many coils means two coils. Okay, wattmeter is having two coils. Okay, one will be the current coil and another will be the potential coil. Okay, so in a short time I will teach you something. Okay, just understand, in a short time I will teach you some more bits. Okay, from this diagram only we can get so many points. Okay, so this is called current coil, this is called potential coil, and this is the load. Okay, so these two coils. Okay, so these two coils together called as a wattmeter. Okay, so wattmeter. Understood, right? So now thing is, you have to answer. I will directly asking some question to you. See whether you can able to answer or not. Okay. So whatever question I am asking, so that's a important questions. Okay. Yes. See, current coil of wattmeter need to be connected. Tell me where it has to connect, in series or in parallel with load. Tell me current coil where it has to connect, in series or in parallel. In series or in parallel, just answer everyone. It has to connect in series, right? By seeing here only we can able to answer. See, these are so important, the diagram or circuit whatever you are just giving here. Okay, so those are, from those only you can get so many points. For the wattmeter, how many coils are there? Two coils are there. Okay, so one is the current coil. What it will do, whatever load current. Okay, so whatever load current. Okay, so that load current will carried by this current coil. That's why current coil need to be connected in series. Now one more, potential coil, potential coil will be connected across the load. Okay, across the load, otherwise parallel with load. Is it clear or not? Potential coil where we are connecting, across the load, otherwise parallel with load. Understanding, right? So these are the important points only. Okay, but you see one thing, I have connected one resistance, right? Yes or no? It will be in terms of 10 kilo ohms. Why we have connected this one, you know? Why we have connected this one? Because this potential coil will carry more current if there is no high resistance. See, in this path, if less resistance is there, then it will carry more current or not. That's why whatever we are connecting in parallel, it should have high resistance or less resistance. High resistance or less resistance. It should have high resistance. I told you, right? Blindly remember something. Okay, whatever you are connecting in series, it should have low resistance. In whatever you are connecting in series, low resistance. Whatever you are connecting in parallel, it should have high resistance. Okay, now tell me, potential coil should have high resistance or low resistance? Answer my question. Okay, potential coil should have high resistance or low resistance? High resistance. Okay, potential coil is having a high resistance. These are all the bits. Okay, whenever in the exam if you get doubt, just draw this circuit. Okay, draw this wattmeter connection, immediately you can able to get everything. It is connected in series or parallel, that's it. Okay, if it's connected in series, low resistance. If connected in parallel, high resistance. Okay, so that's what. Now tell me, current coil is having high resistance or low resistance? Current coil is having high resistance or low resistance? Everyone. Okay, everyone need to answer. It is having low resistance. Okay, and one more, you want more bits like this? I can give within 2 minutes, you can learn two more bits. You see, So what is the formula for resistance? Formula of resistance is R equal to rho L divided by A. Okay, rho L divided by A. Now tell me, for the current coil, resistance is low. Yes or no? For the current coil, resistance is low. Resistance need to be less means, or low means, what will be the length? What will be the length? Resistance need to be less means, what will be the length? Length is less, definitely. Length is low, very less length. Understanding, right? Less length means more turns or less turns. Tell me, more length less length means more turns or less turns? More turns or less turns? That's why you see here. Okay, here see what I have mentioned. Less turns or more turns I have mentioned here. Only 2 turns I have given like this, because it is current coil, so it should have less turns. Understood, right? So that's why current coil should have how many turns? Less turns. Turns means just like turning these 2 turns like this. Okay, understanding, right? Now similarly, to get less resistance, what will be the area of cross section? This area of cross section, tell me, area of cross section, what it is? It should be more or less? It should be more. Okay, that means thick or thin. I'm calling thick or thin. We have to use, for the current coil, we have to use thick wire or thin wire? Thick wire or thin wire? Thick wire we have to use. Understanding, right? So why it is, why we have to use a thick wire? Because area of cross section need to be more, then only this complete value will become low. We want, for the current coil, we want less resistance. That's why, tell me, what we have to use? The thick wire we have to use. Okay, so thick wire we have to use for the current coil. Understanding, right? And similarly, for the potential coil, okay, some people may know this one as the pressure coil. Okay, pressure coil or potential coil, whatever it is, it's same only. Okay, so for the potential coil, I will always call as potential coil only. Okay, now tell me, potential coil, whether it will be thick wire or thin wire? Answer. For the potential coil, it will be thick wire or thin wire? Thick wire or thin wire? R equal to rho L divided by A. Same formula only. You see one thing. Okay, we have not even started the power factor, all this, what we call power measurement. Okay, we have not started power measurement, we have not started watt meters. Still we can able to answer some of the questions. Okay, these are called the basic points. Understanding, right? So you see, potential coil, otherwise pressure coil, it is connected in parallel means it should have high resistance. Whenever it is having high resistance, okay, whenever it is having high resistance, so definitely length should be more and area of cross section must be less. Okay, area of cross section is less means we have to use which wire? Thin wire we have to use. Okay, thin wire we have to use. And similarly, one more, length is more means more number of turns or less number of turns? Length should be more number of turns or less number of turns? More number of turns. Are you understanding? Answer everyone. More number of turns. Okay, you see, these are like so many points. Okay, I'm not sure whether you have like you're this much faster, you are just answering without even starting the subject. Okay, you can able to get whatever we discuss here. Are you understanding? I have just given some of the basics. Okay, only from the circuit you are giving these points means once we understand the subject, okay, it's like even more. Okay, we can able to achieve whatever we want. Okay, so very less time is there. Think about that. Okay, start your preparation. Okay, so start attending the classes from today or tomorrow only. Okay, so then it will be more useful for you. Okay, we all having the knowledge. Okay, so we just need that 1 or 2% or 10%. We need to push up ourselves, right? Okay, that's what we will be doing here.
Hello, sir.
Yes, sir.
Shall we stop for today?